Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem number 20. Okay, fluid mechanics, problem number 20. As usual, we first come towards the statement. Three liquids that will not mix are poured into a cylindrical container. The volumes and densities of the liquids are 0.50 liter, 2.6 gram per centimeter cube. 0.25 liter, 1.0 gram per centimeter cube, and 0.40 liter, 0.80 gram per centimeter cube. Okay, in other words, three sets of volume and density are given. Okay, first set is this 0.50 and 2.6. Second set is this, that is 0.25 liter and 1.0 gram per centimeter cube, and third set is 0.40 liter and 0.80 gram per centimeter cube. Okay, what is the force on the bottom of the container due to these liquids? Dear students, we know that according to Newton's second law of motion, F is equal to ma or F is equal to mg. Okay, where g is acceleration due to gravity. Okay, or w equal to mg. Okay, so in terms of force, actually we have to find out weight W, and because there are three sets of quantities, so three weights will be found, that is W1, W2, W3, and at the end gross weight will be the sum of these three weights. Okay, moreover, what is the force on the bottom of the container due to these liquids? Moreover, it is given as a hint or as a conversion factor that 1 liter equal to 1 liter equal to 1000 centimeter cube. Okay, ignore the contribution due to atmosphere. Dear students, this hint is not necessary to be given. Okay, because it can be found from table of conversion factors. Okay, so whether it is given or not, it does not make very much difference. However, it gives a direction that we have to convert liter into centimeter cube. Okay, because from table of conversion factors we will see a lot of such conversion factors in which liter will be given in various other forms. Okay, anyhow, now we come towards the solution of this problem. Okay, dear students, we have already stated that three sets are given. Okay, so dear students, while solving such problems, we have to analyze the data given. Okay, there are three types of data in such problems. Okay, one type of data is that which is expressly given in this statement. Second type of data is that which we are required to find. Okay, And the third type of data is that which is not provided in the statement but is contained in table of physical constants given in appendix at the end of a textbook. Okay, so relevant or concerned physical constants are also deemed to be a part of the statement. Okay, so here for example, in this statement acceleration due to gravity, that is 9.8 meter per second square, is not given anywhere, but it is given in, it is a physical constant and it is given in table of physical constants. Okay, so even if this data is not provided in the statement, it is assumed that we know that data. Okay, solution. Let us analyze and designate the given and required data as, okay, v1 equal to this, rho 1 equal to this, and w1 equal to sign of interrogation, that is it is to be known, it is to be determined, it is to be found, it is to be we have to find out this. Okay, volume and density are given and we have to determine weight. Okay, there are three sets, so we have denoted these values as volume 1 rho 1 w1, volume 2 rho 2 w2, volume 3 rho 3 w3. Okay, moreover, it is given in the hint that 1 liter is equal to 1000 centimeter cube. Okay, moreover, g equal to 9.8 meter per second square acceleration due to gravity. This is not given in the statement, but it should be assumed as a part of the data provided in the statement. Okay, so dear students, there should be no difficulty, quite simple, because we know that density is equal to mass over volume, and from that expression mass is equal to rho into volume. Okay, w1 is equal to mg. Here m will take the form as m1 m2 m3. Okay, because three sets are under consideration. Okay, dear students, we start our solution in the same pattern as our most of the previous problems have been started. Okay, density is mass per unit volume. If a mass m of a homogeneous material has volume v, then its density rho is given by rho equal to mass over volume m over v, equation number 1. Okay, rearranging equation number 1 as m equal to rho into v. Okay, density into volume. Okay, we get, dear students, m is equal to rho into v, mass is equal to density into volume. Okay, this, with respect to this problem, this expression takes three different shapes. Okay, that is m1 will be equal to rho 1 v1, m2 will be equal to rho 2 v2, and m3 will be equal to rho 3 v3. Okay, we get m1 equal to rho 1 v1, m2 equal to rho 2 v2, and m3 equal to rho 3 v3. This implies that because w is equal to mg, so w1 will be equal to m1g, w2 will be equal to m2g, and w3 will be equal to m3g. This implies that. Now we are putting the values of m1, m2 and m3. Okay, this row contains three values of masses. Okay, m1, m2, m3, and in we will put these three values in these three equations. Okay, all these three equations are written in a single row. Okay, W1 equal to rho 1 V1 G, W2 equal to rho 2 V2 G, W3 equal to rho 3 V3 G. Okay. Hence, W1 equal to rho 1 V1 G equal to 2.6 into gram over centimeter cube into 0.50 liter into 9.8 meter per second square. Dear students, simplification of all these terms give us the result W1 equal to 12.74 Newton. Okay. There is almost no need to explain this simplification sequence, okay? Because in our earlier classes we have dealt with these steps so comprehensively that there is no need to explain here simplification steps, okay? However, in order to remove any confusion, it is explained that in place of L, that is liter, 1 liter, because 1 liter is equal to 1000 cubic centimeter, it is given in the statement, okay? And even if this conversion factor is not given in the statement, we can found this conversion factor from table of conversion factors, okay? But here in this problem we will not show table of conversion factors, because the only conversion factor which we need to use in our problem is expressly given in this statement, okay? So we leave this table of conversion factors to be included as a part of our solution, okay? Moreover, dear students, acceleration due to gravity is given as 9.8 meter per second square. Here, as liter is converted in terms of centimeter cube, so here again we have converted meter into centimeter, because we know that 1 meter is equal to 100 centimeter, okay? I think it is quite clear, no doubt. Dear students, moreover, from here centimeter cube will be cancelled out with centimeter cube, okay? This will be cancelled out, and we will get the result 12,74,000 gram centimeter per second square, okay? Then once again we have, actually dear students, to this extent we can directly express it as Newton, but in MKS system, because Newton is a kilogram meter per second square, so we again convert gram and centimeter into kilogram and meter, okay? When we will convert gram into kilogram, we will have to multiply it with the 10 raised to the power minus 3, okay? Then it will become kilogram. Similarly, when we will convert meter into centimeter, then we will multiply it with 10 raised to the power minus 2, then it will become meter, okay? So our result will become 12.74 kilogram meter per second square, and we know that this is the definition of Newton, okay? So in place of this kilogram meter per second square, we can write Newton. So our answer has become 12.74 Newton. Okay, so we have found solution of the first there were three portions of this problem, three combinations, okay, and we have to find out W1, W2, W3. So here we have found W1, which has become equal to 12.74 Newton. Now we move towards W2. Okay, similarly W2 equal to, again, same steps, no addition, no subtraction, except the value that values of density and volume will be changed. Okay, here density is 1.0 gram per centimeter cube and volume is 0.25 liter. Okay, then again same as in W1, we have converted liter into centimeter cube, similarly meter into 100 centimeter. From here centimeter cube will be cancelled out with centimeter cube and we will be left with this value. And from here we have again converted gram into kilogram and centimeter into meter. So we have gotten 2.45 kilogram meter per second square, and we know that this is equal to Newton. So W2 has finally become equal to 2.45 Newton. Similarly, we will find W3. Okay, and W3 is equal to rho 3 V3 into acceleration due to gravity. Same procedure, same steps, except the value that here density is 0.80 gram per cubic centimeter and volume is 0.40 liter. Okay, so again liter has been converted into 1000 centimeter cube, meter has been converted into 100 centimeter. Okay, here centimeter cube will be cancelled out with centimeter cube and we are left with 313,600 gram centimeter per second square. We again move back towards the kilogram meter. So we will multiply it with 10 raised to the power minus 3. Then in this case gram will become kilogram and into 10 raised to the power minus 2. In this case centimeter will be converted into meter. Okay, so we will be left with this expression. Okay, 3.136 kilogram meter per second square, and we know that this expression is equal to Newton. So our W3 has become equal to 3.136 Newton. Okay, what are these? These are three forces, these are three weights. Okay, but we are concerned with the total force and total weight. Okay, now that is, we are concerned with W, not W1, W2, W3. Okay, now W is equal to W1 plus W2 plus W3 equal to this. Okay, when these three weights are added, we get a W equal to 18.326 Newton. Okay, W equal to 18.326 Newton. This is our final solution of the problem. Now we come towards the reference book from where this problem has been chosen. Okay, reference book is Fundamentals of Physics Extended. Its authors are Holliday and Resnick and Jarl Walker. Its publisher is Wiley and its 10th edition 2014 or 11th edition having been published in 2018 has been adopted or followed. And here chapter number 14 under title Fluids is the concerned chapter, and here the problem under consideration is enumerated at serial number 4 of the exercise given at the end of this chapter, that is exercise number 14.4, and this is the end of our module. Okay.